Bloop was an ultra-low frequency and extremely powerful underwater sound detected by the U.S. National Oceanic and Atmospheric Administration (NOAA) in 1997. In 2002 it was said to be consistent with large marine animals, though it was also consistent with the noises generated by icequakes and large icebergs, or large icebergs scraping the ocean floor. By 2012 NOAA concluded that the noise was ice-related. Analysis: the sound source was roughly triangulated to 50 degrees south 100 degrees coordinates 50 degrees south 100 degrees west, a remote point in the South Pacific Ocean west of the southern tip of South America, and the sound was detected several times by the Equatorial Pacific Ocean Autonomous Hydrophone Array. This system was developed as an autonomous array of hydrophones that could be deployed in any oceanographic region to monitor specific phenomena. It is primarily used to monitor undersea seismicity, ice noise, and marine mammal population and migration. 284 This is a standalone system designed and built by NOAA's Pacific Marine Environmental Laboratory (PML) to augment NOAA's use of the U.S. Navy Sound Surveillance System (SOSUS), which was equipment originally designed to detect Soviet submarines. According to the NOAA description, it rose rapidly in frequency over about 1 minute and was of sufficient amplitude to be heard on multiple sensors, at a range of over 5,000 kilometers 3,000 miles. NOAA's Dr. Christopher Fox, interviewed by David Wolman for an article in New Scientist, did not believe its origin was man-made, such as a submarine or bomb, nor a familiar geological event such as a volcano or an earthquake. Fox stated that while the audio profile of Bloop does resemble that of a living creature, the source was a mystery because it would be far more powerful than the calls made by any animal on Earth. Wolman states in the article that Fox initially speculated Bloop to be ice calving in Antarctica, but later came to believe the sound to be like that of an animal in origin. Fox's hunch is that the sound nicknamed Bloop is the most likely to come from some sort of animal, because its signature is a rapid variation in frequency similar to that of sounds known to be made by marine beasts. There's one crucial difference, however. In 1997 Bloop was detected by sensors up to 4,800 kilometers 3,000 miles apart. That means it must be far louder than any whale noise, or any other animal noise for that matter. Is it even remotely possible that some creature bigger than any whale is lurking in the ocean depths? Or, perhaps more likely, something that is much more efficient at making sound? David Wolman. According to author Philip Hayward, Wolman's speculations amplified Fox's hunch, and through the use of the word likely opened the door for subsequent speculation as to what such an efficient noise-making entity might be. Over the last decade, consensus has, in fact, supported the argument that the noise is produced by ice fracturing processes. Icequake origin. The NOAA Events Program has since attributed the sound to that of a large icequake. Numerous icequakes share similar spectrograms with Bloop, as well as the amplitude necessary to spot them despite ranges exceeding 5,000 kilometers. This was found during the tracking of iceberg A53A as it disintegrated near South George Island in early 2008. The icebergs involved in generating the sound were most likely between Bransfield Straits and the Ross Sea, or possibly at Cape Adair, a well-known source of cryogenic signals. Sounds generated by icequakes are easily determined through the use of hydrophones, since seawater, an excellent sound channel, allows the ambient sounds generated through ice activities to travel great distances. 5. Ice calving. In ice calving, variations result from a sound source's own motion. 55 As oceanographer Dr. Yun Bochier explains, the alteration of waveforms from a detected sound can also be caused by so-called angular frequency-dependent radiation patterns associated with antisymmetric mode motion of the ice cover. 59. Rubbing and ridging events within an ice flow. Two processes known as rubbing and ridging are responsible for acoustical emissions similar to those from ice calving. Rubbing involves two or more areas of compacted glacial ice flows which are being forced together, inducing shear deformation at its edges and triggering horizontally polarized shear waves, i.e., SH waves. 137 Ridging occurs when that ice bends or slides at the ridges. 121 According to Dr. C.A., both events will produce sound in the failure sequence breakup of an ice flow. A wave equation resulting from shear deformation will be defined in an ice flow with the rubbing effect coupled to the flow through its boundary with the adjacent ice. 137 While ridging deformations revealed by this event indicate that the failure process is associated with a crushing process that seals air or vacuous gaps between ice flows. The acoustical signals emitted by this failure process are similar to those emitted from a collapsing air bubble in a fluid. 121. Popular culture. A 2012 American made-for-TV thriller produced for Animal Planet and Discovery Channel in the form of a documentary titled Mermaids. The Body Found used the Bloop sound as evidence for the existence of mermaids or an unknown species in the oceans. NOAA posted a refutation on their website. The deep, A 2015 Australian/Canadian co-produced animated television series featured the Bloop in episode 23, Bloop, to suggest that it was a new unique species of communicating coral threatened by an underwater mining machine. An Atomic Robo mini-comic presented a theoretical cause of Bloop in 2016.